really is an Apple, just not Apple. This thing has exactly one job. Flip the power switch, play a few children's songs, and loop the same cute animal animation over and over until the batteries die. Even the keyboard, mouse buttons, and touchpad are completely fake. They're only there to make it look like a real laptop. So today I'm going to do something it was never designed to do. I'm turning this toy laptop into a real gaming laptop. Let's get started. First, let's take a closer look at the laptop itself. I'm not admiring the design or anything like that. I just need to figure out whether it's physically possible to fit new hardware inside. The first thing that caught my attention was the thickness. At around 3.5 centimeters, it's surprisingly chunky, but that's not really the problem. The real problem is how tiny it is. I searched through my entire collection of spare parts, but I couldn't find a single motherboard that would actually fit inside this chassis. And it's not just the motherboard. The display is incredibly small too, only about 13 centimeters wide. That makes this project much harder than I expected, because finding a screen that small isn't easy at all. Just when I was running out of ideas for what hardware could possibly fit inside this toy laptop, I stumbled across something pretty interesting. A miniature Android desktop computer. These little machines are typically used as information kiosks or digital advertising displays. I picked this one up as surplus from a convenience store. Now let's see if it still works. Look at that! The Android logo. So this little computer is still alive. Unfortunately, it's pretty old. It's running Android 6, which definitely shows its age. Even so, it's packed with some surprisingly clever hardware. It has a smooth 7-inch touchscreen along with a decent selection of ports, including mini HDMI and even gigabit Ethernet. Not bad for something that was never meant to be a consumer PC. As for the performance, we'll save that for later, because now comes what might be the hardest part of this entire project. I'm somehow going to fit this entire Android mini PC inside a toy laptop. So, the first step is taking the toy laptop apart. Getting inside the toy laptop was actually pretty easy. All I had to do was remove the 4 screws on the bottom. Once I opened it up, I couldn't help but laugh. The inside was about as simple as it gets. There were only 2 tiny circuit boards and a single speaker, which makes perfect sense when you remember what this thing was originally designed to do. So the first job was obvious. Everything inside had to go. Every wire, every board, every unnecessary part. Next, I removed the display assembly. Wait, what is this? Instead of a real screen, there's just a printed picture being moved by a tiny 1-watt motor, almost like a miniature conveyor belt. It's a clever little toy, but that's about it. I'm not going to spend too much time talking about it because every bit of this space is about to be replaced with something far more interesting. Thankfully, there aren't many parts inside, so stripping the entire toy down only took a few minutes. Now it's time to take apart the Android mini PC and see what we're working with. This small green board you're looking at is the heart of the entire system. It combines the CPU, RAM, and storage onto a single compact motherboard. For a project like this, that's almost perfect. It's tiny, efficient, and incredibly easy to work with. So I disconnected all of the cables and lifted the motherboard out of its original case. Next came the display. Fortunately, it was only held in place with adhesive strips, so removing it was surprisingly easy. Now comes the fun part, figuring out how to fit everything inside the toy laptop. The display cable is extremely short, so the motherboard has to sit directly behind the screen. Then I'll add 4 lithium battery cells to power the entire system. After moving everything around for a while, this is the layout I finally settled on. The first step is mounting the new display into the toy laptop. To make it fit, I need to remove a few unnecessary plastic pieces and trim away several support tabs so the panel can sit perfectly flush with the top half of the case. Since the replacement display is slightly larger than the original opening, I also have to cut away part of the plastic bezel that's blocking the screen. Once that's done, the display drops right into place. Honestly, the fit is better than I expected. To secure it, I'm using hot glue on all 4 corners. It's simple, but it's more than strong enough for a project like this. With the display locked in place, it's time to figure out where the motherboard will go. Unfortunately, the original plastic standoffs get in the way, so they have to be cut out as well. While I'm at it, I'll cut a small opening along the top edge so I can still access the external ports. I'll fast forward through this part. About 15 minutes later, everything is finally trimmed to size. Originally, I planned to mount the motherboard using 5mm standoffs, but the mounting holes are much smaller than I expected. So instead, I'm using smaller screws and reusing the plastic mounting posts that were already molded into the toy laptop. Then I reinforce everything with super glue. Honestly, it's way more solid than I thought it would be. Next comes something every laptop needs, a webcam. Luckily, the Android Mini PC already has one built in, so I removed the camera module, drilled a small hole in the front of the toy laptop, and mounted it in the perfect position. Just like that, this toy laptop officially has a working webcam. Now comes what might be the most time-consuming part of the entire build.
إتادوري، أنا أحتاج إلى قوتك.
Time-consuming part of the entire build. Getting rid of all these plastic supports inside the case. After nearly 30 minutes of cutting, trimming, and cleaning, I finally had enough space to fit the rest of the hardware. For power, I chose 3.7-volt lithium batteries. The first step is securing all 4 battery cells firmly in place. Then I wire them in parallel, increasing the overall battery capacity while keeping the voltage the same. Of course, that creates another problem. The system needs 5 volts, not 3.7 volts, so I'll add a DC boost converter to step the voltage up. Now, let's see if it actually works. Perfect. After running through the boost converter, the output is now just over 5 volts. Exactly what I was hoping for. The next step is identifying the positive and negative power terminals on the motherboard. Once I know which is which, I can safely feed power from the battery pack without risking any damage. After confirming the polarity, I solder 2 wires directly to the power input. I'll connect these to the battery pack a little later. Next up is the power button. The original switch is tucked away in a spot that's almost impossible to reach once everything is assembled. So instead, I trace the 2 contacts that are shorted when the button is pressed. Then I soldered a separate momentary push button to those contacts, giving me a much more convenient external power switch. The last thing I wanted to relocate was the USB port. I didn't want all my USB connections sticking out of the top edge of the laptop, so I salvaged a USB port from an old circuit board instead. After removing it, I soldered its 4 wires to the corresponding USB pads on the motherboard in the correct order. This lets me position the USB port wherever it's most convenient, instead of being limited by the original layout. Next, I needed to separate the Ethernet port and wire it directly to the motherboard. Once that was done, I mounted both the Ethernet and USB ports on the back of the toy laptop. But before any of that, I had to take some careful measurements and trim a few sections of the plastic so everything would fit together perfectly. With that finished, I connected the power wires to the battery pack, and at this point, the project was finally starting to come together. The next step was adding a charging circuit. I decided to reuse the same charging board with the built-in LED battery level indicator that I used in my previous build. It's compact, practical, and fits this project perfectly, so I mounted it right next to the USB and Ethernet ports. Now it was time to install the power button. I wanted it to stay in the toy laptop's original location, so I mounted a small tactile switch underneath and attached the original power button cap on top. And honestly, I'm surprised by how good it feels. The click is actually really satisfying. Now for one of the most important parts of any laptop, the keyboard. Unfortunately, the original keyboard on this toy laptop wasn't a real keyboard at all. It was just a single piece of molded plastic made to look like one. Yeah, so I picked up this ultra-compact Bluetooth keyboard instead. It's small enough to fit the overall design, although it's a bit shorter than the opening left by the original fake keyboard. To make it fit properly, I fabricated a custom PVC mounting plate and cut out an opening that matched the dimensions of the new keyboard. I chose this particular model because it's incredibly convenient. It connects over Bluetooth, has a built-in rechargeable battery, and charges through USB Type-C. But since this laptop already has its own battery pack, I removed the keyboard's internal battery and wired it directly to the main power system. That way, I never have to worry about charging it separately. Once everything was wired up, I secured the keyboard to the PVC plate, then cut a matching opening in the top shell of the laptop so the entire assembly could drop neatly into place. At this point, everything was finally ready. All that was left to do was put every piece back together and turn it into a complete laptop. And it's done. Honestly, from the outside, it looks surprisingly adorable. What's even cooler is that it actually has all the essential features you'd expect from a real laptop. Alright, the moment of truth. Let's see if it actually powers on. 3, 2, 1. Oh my god, it works! I was seriously so happy I could have cried. I honestly never imagined I'd end up building something this weird and somehow make it actually work. Alright, next. Let's connect a wireless mouse and see what it's like to use. This is honestly kind of insane. Everything works way more smoothly than I expected. Even the Bluetooth keyboard responds really well, and the overall experience feels surprisingly polished. Now, the hardware itself is pretty modest, so performance is definitely limited. As you can see, even YouTube videos only play smoothly at 480p. But considering what this machine actually is, I'd say that's still pretty impressive. As for the speakers, they're honestly much better than I expected, especially for a project like this.